Online as our major source of fun this week. Up on Canvas, has everybody seen the study guide that I posted? Where did I post this? I missed my keyboard shortcuts. Bingo. Okay. Anything in particular that you guys want to go over from this study guide, or would you like us to just kind of start by running through it in its totality? And then maybe we go to the command line, we do a couple commands, and we try a practice programming problem? That sound good to everybody? Anybody have any particular requests? One thing that we will be very clear about, and I'll say this again in class tomorrow. When it comes to quizzes and exams, if we say something is non-examinable, we mean it. Does that make sense? We will never try to pull a fast one on you guys. We will make the questions challenging. We will make you think. We will make you pull in other concepts from other classes. But if we say that something is not examinable, right? And that doesn't mean that it's not on the study guide. It means that when we say this will not be tested, it will not be tested. There is nothing from this week that is off limits on the test because there is nothing on the study guide that says that there's nothing, off limits. But I think I have pretty much covered most of what we've done this week. So we can start here. Anybody want to? We'll pull out the prizes and just start to throw duckies around and answer questions. Yep. Make sure your screen recording stuff. Oh. Ooh. Yes. It's been a long time since I have Zoomed. So yes. Better now, Anthony? Let's see. Yeah, that's good. Cool. Is that better? Yeah, that's good. Cool. All right. Unsigned types. What is an unsigned type? Larger range because of what? What happens? Using one of the bits for the sign being negative or positive. Correct. The actual width of the We're talking about the range, the width of the range. The actual number of bits is still the same, whether it's signed or unsigned, but the way that we use them is different, which makes it that we're not using that negative half. We're shifting that negative half over to more positive. Everybody good with that? Ducky for you. Darn, I suck at sports. And of course, Ducky for you as well. I don't want to hit computers. Cool. All right. If we set an unsigned type to a negative value, what happens? All right, there we go. When would you want to use an unsigned type? Okay. However, bonus question, if you're using an unsigned type and there is the possibility of underflow, what do you need to take care of when you use something of that nature? Bounds checking. If you're going to use an unsigned type for something that could underflow, you want to give yourself the ability to check on that. It's just a critical thinking question. Will not be on the quiz tomorrow. We good? I was purely for critical thinking. This, hint, hint, nudge, nudge, hint, hint, nudge, nudge, will most certainly, in some way, shape, or form, show up in somehow. I think every member of the course staff can agree. This will be there in some way. So let's go through it in great detail. What default values are assigned to your variables in C++? Primitive types, fundamental types, not standard library types for those of you who are looking. We are talking purely about things like integer and character and double, float, unsigned stuff. Beautiful. Junk. No, it does not. Great question. And at some level, I should rephrase that because there is a technicality there.
Data that's stored there might be different, but it's still going to be garbage. You're still reading.
Correct. That was exactly what I was about to say.
Can't use. If I initialize it to like null, well, like what would be there? You can't. You can't initialize to well or.
You can it's a good question. So technically you could. It's very old practice at this point. You're better off to initialize to 0 or something of that nature.
Technically. Technically, when you say int x equals all caps null, that's actually null is actually just a stand-in for 0 on pretty much every compiler I can think of. So you might as well just say int x.
Correct. So Anthony just pointed out, and he's entirely correct, that null is pretty much a stand-in for 0, capital NULL. Honestly, at this day and age, I don't see it used all that frequently in modern C++ development or even traditional C++ development, but it is there, so it is true. Memory junk, garbage. There's nothing. Correct. Truly, this is the one time where I don't know would get you 100% credit on a question because you just don't. All right. What value should you use for initialization? For with potentially one exception. There we go. You're not gonna have a string. You could do the empty string. Sure. Booleans are weird. In C++, and we haven't gotten here yet, Boolean, 0 maps to true. Excuse me, 0 maps to false. Everything else maps to true. Okay? 1, 4, 9, -2,000,000, the character C, like anything else. Right? They could be represented as an integer or implicitly converted to an integer. We haven't gotten there yet. That's tomorrow. Bools, it's basically, it depends on what you're trying to set the default value to. You should use true or false.
You're typically not going to declare a bool and then just like not know what it is. You're usually just going to say bool equals some Boolean expression and then.
Check, check. I'm giving you a microphone.
Fair enough. Should I parrot that back?
Yeah, probably should for the Zoom people.
Hopefully it's coming through. So for a Boolean value, you're typically not going to like initialize it to just like bool x semicolon. You're usually going to have some idea of what your bool is going to be. So for example, you might have like bool x equals the return value of some function that does a Boolean calculation.
Correct. All right. How are variables stored in memory? There are memory stacks in C++. We haven't, it's probably a little bit too high level an answer for where we are right now in the class. But yes, that would be a very appropriate answer and would get full credit. At a very basic level, when we put the contents of a variable into memory, what is it translated to in the computer? There we go. That's what I'm looking for. Zeros and ones, right? Okay. When presented with multiple errors after building a program, which errors should you look at and fix first? That's a pretty good starting point. If you attack, there is a plan of attack when it comes to errors. Okay. Go for the easy ones first. The ones that are easy to understand. Your compiler will yell at you and say things like missing semicolon. What's funny is that when you fix a lot of those errors, a lot of the other ones magically disappear. Does that make sense? The compiler is going to yell at you pretty much in the order that it thinks you need to touch the stuff. Will warnings affect whether your code compiles? Will warnings affect how your program runs? No.
I mean,
It could be warning you towards a runtime error,
yeah.
but does it affect how your program runs? No. Should warnings be ignored? Also no. Compilation. Be sure to know what each of the flags in the compilation command does. I took some time and put together for you guys a full list of the compilation command. So, without going through piece by piece, G++, what is G++? Anybody remember the name of the compiler? Very good. GNU compiler. W all. Warning all. What does warning all start us with? Ba basic warnings. W extra. Okay, can you give me any specific warnings that come specifically from W extra? We mentioned one. Okay. Unused parameters. I also mentioned tangling references here because you will see those quickly, but you're not required to know them. But we talked about how function parameters, right, that aren't used are an overhead. Our optional flag W error. Anybody know? There we go.
And that's like the one case where warnings will actually fail your compilation process because you told the compiler, if there's a warning, just stop, throw an error.
Correct.
Don't let me compile.
All right. This STD thing. Perfect. I'm going to say it for the Zoom people. It's using C++ 20 to compile. Taco. Perfect. And then hello.cpp. Source file that you're trying to compile. Very good. There will be things that we add to this flag throughout the semester. Occasionally, you will see some other things like attack L. But for now, this is our base. Okay. Questions on this compilation command, because this is super important. I will tell you why. On your programming quiz tomorrow, do not be surprised if you have to type this in. Okay. We've typed it in 5 million times. I think we can do this on a quiz. We'll also very quickly run our way through Hello World. We've done this enough times, but I want to make sure everybody feels comfortable. So I will ask for questions. Preprocessor directive, the pattern include. Everybody good? Copies and paste from the standard library over to your program. Statements ending with semicolons. These compile the machine code. We have a function main. By convention, it returns 0 for success to the operating system. Error code if unsuccessful. Must be an int. I will drop back up here. This is your parameter list or your function arguments, right? Important to know, this is an empty parameter list, or there are no function arguments, no arguments being passed to the function. But because it is a function, you can pass arguments here, and in a couple weeks we will. And of course, we have standard namespace, this funky operator. Anybody remember the name? This is the scope resolution operator, because it tells us that, you know what? I'm going to put it this way. Why would we use a scope resolution operator to tell us to look in the standard namespace? Why would it be called a scope resolution operator? So it's not outside of the scope of the standard library, but it's in the standard library, right? We're pulling it in from the standard namespace. It's saying, look in the standard namespace, right? Look in that namespace and get C out. Does that make sense? So it's in the namespace scope. We good?
If you want like some more fun, you can go in just type in an IDE standard : and see all the stuff that comes out just from the IOStream library or header file, because
there's more header files that pull other things from the standard namespace.
Yeah, and there's more header files. So pretty much anytime you're pound including something, it's going to be placed in the standard namespace. So basically, anytime you want to use something for one of those pound includes, you're going to do standard : Later on, that might not be true, because we'll have some other libraries for you. Like, for example, we'll be using SFML, which will require you to do SF : So you kind of need to know where this stuff comes from. For right now, standard : is pretty much everything that you need to know.
At least for the next 2 or 3 weeks.
Correct.
All right. Rest of this we just went through. Ah, yes, the insertion operator, before I forget. Takes what's on the right of it, pushes it into a stream, right? Cout is a stream object. We good with that? Endl ends the current line and flushes the buffer, right? Obviously, the return statement we know. Questions on any of that? At a high level, yes, right? It's the buffer is the attempt of the computer to, if you're doing something highly complex, right? And you have a lot going on. It's attempting to use its processing time in a way that makes the most sense. So if you've got a lot going on and you're, waiting to print stuff to the screen, it'll probably like let it sit there for a minute while it does other things, and then it'll print to the screen. Unless you give it something like Endel, which says, no, I want you to do this right now.
Because printing is actually pretty.
Printing
the
is
console is actually
Actually expensive.
really expensive. So for reasons that you'll get into in comp board and
Correct.
probably OS, I think we'll talk about it.
They do. I will. If you're wondering why I'm being hand wavy, it's because there are a bunch of concepts in that you don't know yet. But I will tell you that printing to the console is incredibly expensive. So unless you tell your computer to do it right away, it's going to wait to do that all at once. Cool. I was going back up here. All right, and then we're gonna finish this up. Kernel, shell, and terminal. Questions, comments, concerns on the kernel, shell, and terminal. Do we access the shell directly? Why do we need a terminal emulator? What is the terminal? It wraps around the shell. Exactly. Yep. All right. The structure of the Unix file system. It's a hierarchical structure. Can be easily represented as what? A tree. Very good. Actually, I'm going to connect my laptop because I think we should play with the command line for some of this. And I forgot that I actually brought and I need to figure out how to share this on Zoom simultaneously. But I did. No. All right, if I go to laptop, I actually did bring a little thing for us to go through and work through the command line a little bit.
It's still streaming the original computer on the.
Oops. It'll take me a minute to switch.
Recording stopped. Recording in progress.
I'm recording over the NAS, so it should be fine.
Okay, perfect. Then I'm
Recording
not gonna-
stopped.
Thank you, because it looks like Zoom is not recording because it only recorded on that computer. So let me. All right. Cool. Quick reminders, we all know the difference between a GUI and a CLI. Skip this, but I will do this. Definition of the command line. An interface where the user types in commands and hits enter to execute said command, right? When we talk about a command line, that's one easy definition of it. We talk in this class a lot more carefully. We talk about the shell, right? As a program that processes commands via a terminal. It's the connection between you and the kernel, right? The terminal is the application that provides a window for interacting with the shell. It's a wrapper around the shell, right? And in the context of the command line, we deal with tokens, right? Or words. These are sequences of characters that are considered single units. Not often that you'll hear that in our class, but important to know because token is a word that we will use quite a bit in various contexts in programming. So I want you to understand that it has multiple uses. There are ridiculous numbers of shells, okay? We're only using the bash shell, but there are more shells than I can even begin to mention. I picked a couple. Gone through this. We know how that works. We should probably talk about this. Formal definition for a file. Sequence of logically named bytes, right? Then there's a directory, which is a file that contains references to other files. You'll often hear this referred to as a folder in, common practice. Path. Address or location of a file system object. There's two types. Absolute and relative paths. We kind of know, right? Absolute path, got to give it the whole thing from the root directory. Relative path gives it relative to wherever the working directory is. By default, okay, when we just get into a bash shell, what is our working directory? Very good. It is the user's home directory. In a minute, I don't know if I actually have mentioned this heavily, but most of your stuff in this class will have relative paths because in order for us to compile your stuff, it needs to be relative to whatever we are using on our computer. Because if you give us, for example, C slash, slash mount slash C slash user slash, Gabrielle slash what have you, we're not going to be able to find that file on our operating systems. And we're going to get an error when you don't mean for it to be. Instead, you can use some special commands, relative paths from your working directory. Anybody remember the dot and the dot dot? Those were great in relative paths. So I made us a simple example here. And I thought we could go through together and try to create this file structure in WSL. All right. Let me.
How are you using the font there?
Control plus.
That work? Oh, I didn't know that.
All right. What I want to do, I think I can do this. I can move this over here. If y'all want to join me in your command line, you are more than welcome to. We are going to find our way through this directory and make a bunch of folders and some files and traverse through it. So if I want to make our top directory here, right? First step. There we go. All right, I'm there. I want to get into it. We're in. Next person that wants to give me a shout here. What what would be our next path here? I was trying to make this directory. Two ways we could go. We could make directory projects, sure. Very reasonable way to go. All right. I'm now where? If I was to print my working directory right now, where would I be?
You would still be,
I would still be in the CF354C. If I wanted to make a directory, let's say the project 0 directory, right from here, can I do it? If so, how? So you're saying we do mkdir. Let's go take a look. ILS. I have projects. I go to projects, ILS. I have project 0. Completely correct. Everybody see how we can traverse up and down that tree like that? That works for multiple things. So if I'm here in the projects folder, right? And I want to create hello world.cpp or tic-tac-toe.cpp or prisoners dilemma.cpp or anything from here, what could I do? If I wanted to make the file, right? Hello world.cpp in the project 0 directory.
but
I could use touch, sure.
project 0 from other world.
All right. Now, if I go there, I can most certainly know that I have a file. Without going to my IDE, I want to edit this.
Then
Anybody else have any other ideas?
Emacs.
And you're fine. Let's do nano. Good. You could put, you could use it to push commands into the file. Not anything you would have to deal with in this class.
That's what I said. It's good.
The answer would be nano or Vim or Emacs or whatever you wanted to use. But let's use nano. I'm not going to make us code hello world. But I am going to edit this file just a little bit. Now I want to save this. Where do I go? I want to save it and get out of here.
I'm assuming it's Control X.
Control X would bring you to the exit, sure. And exit will let you save a modified buffer. And you can click enter. Everybody good there? How we go into Nano, how we edit text, how we save it. If I wanted to view what I just did and made sure that it worked, how would I do that? Sure. Next option. Les will do it. I'm in less. I'm kind of stuck. What's my out? Just a Q. Everybody good so far? Now, from here, if I want to get all the way back to my 3504C directory. How would I do that?
You could do CD dot dot twice.
Works perfectly. PWD puts me right back in that directory. Everybody okay? Anything else that I really want to make sure we hit? If I want to find the word goes in a file in that directory, what am I doing?
Grep.
Okay. What am I doing? Grep. Okay. And the file name. Sure.
Objects.
Very good. I will give you one other thing that might be of interest to you. You'll notice that grep goes is just going to hang, right? Notice that when I put this dot, I get nowhere, right? Why is that? It's not like I can grep for goes right where I am, right? So far. Let's look in the man page for grep and see if there's anything we can do. Man grep brings us to a help page, right? We're just going to scroll through here, see if there's anything that intrigues us. The important thing that you guys saw here was that we could use man to get to this documentation, right? This is what I'm looking for. But this might be read all files under each directory recursively, following symbolic links only if they're on the command line, right? Now I can search this whole folder because I can do a recursive grep. Everybody good with that? You are not required to know grep tech R. I am simply saying if you didn't know where grep tech R was, where could you go to get it? Man page. Everybody good there? Go.
Our recording needs to be on Zoom or no recording.
I mean, I think we're basically done.
Oh,